If you're building anything in AI right now, you're faced with what seems like a simple hardware choice, Nvidia or AMD. But this isn't like choosing a graphics card for gaming, where the decision might come down to a slight price-to-performance difference. In the world of artificial intelligence, this choice is fundamentally about ecosystems, not just silicon. It's about the path of least resistance versus the path of potential savings. You've probably heard that Nvidia is the default, the king, the undisputed champion. But you've also heard whispers, maybe from a cost-conscious colleague or in a tech forum, that AMD is catching up, that their hardware is competitive, even superior on paper. So what's the real and varnished truth? Is AMD a viable challenger, or is this still Nvidia's world and we're all just living in it? Today, we're going to move beyond the hype and the spec sheets. We're going to dive into the trenches of software support, developer adoption, and raw practicality to answer the question once and for all for your AI project. Which company truly gives you the best shot at success? Let's start by acknowledging the elephant in the room, Nvidia's uncontested dominance. And to understand that dominance, you have to understand that it was built not in the last 2 years, but over the last 15. It all comes down to a single, brilliant strategic move: CUDA. CUDA is a parallel computing platform and programming model that allows developers to use NVIDIA GPUs for general-purpose processing, far beyond just rendering graphics. Think of it as the universal language that allows software to talk directly to the raw power of the GPU. NVIDIA didn't just create this language, they gave it away for free. They seeded universities, they supported research labs, they built an entire generation of AI pioneers and PhD students on their platform. This created what economists call a network effect, but what we in tech call an immense software moat. Today, every major AI framework, PyTorch, TensorFlow, JAX, is built with CUDA as its foundational backbone. When a new AI model paper is published, its code is almost universally written for a CUDA environment. This means that for a developer, getting started with an NVIDIA GPU is as simple as running a standard pip install command. It just works. This seamless, out-of-the-box experience is NVIDIA's single greatest advantage. It's not just about having powerful hardware, it's about having the only hardware that the entire software world is automatically built for. Now, let's talk about AMD's position. For years, AMD's approach to the GPU compute space was fragmented and developer-unfriendly. They relied on open standards like OpenGL, which, while noble in concept, never achieved the performance or ease of use of CUDA. Recognizing this, AMD created its own answer to CUDA, called ROCm, the Radeon Open Compute Platform. ROCm is, in essence, AMD's attempt to build an entire software ecosystem from the ground up. And on paper, and in specific, controlled environments, it's impressive. The hardware itself is not the problem. AMD's Instinct MI300 series accelerators are computational beasts, with specs that often rival or even exceed their NVIDIA counterparts in terms of raw flops and memory bandwidth. The challenge, the monumental challenge, is the software and the community. Installing and configuring ROCm can be a days-long odyssey of dependency hell, incompatible driver versions, and cryptic error messages. It lacks the polished, one-click installation of NVIDIA's software stack. Furthermore, while support for frameworks like PyTorch has improved dramatically, it's often a version or two behind the CUDA implementation. You might find that a brand new, cutting-edge AI model has a dependency that simply breaks on ROCm. This is the practical reality that every developer considering AMD must face. You are choosing a path that will almost certainly involve more troubleshooting, more compatibility headaches, and more uncertainty than the NVIDIA path. So, with all that said, is it ever a good idea to choose AMD for AI? The answer is yes, but only in very specific, well-defined scenarios. The first scenario is for large-scale, hyperscale cloud providers like Google, Microsoft, and Amazon. These companies have the vast engineering resources to build custom software layers, debug deep kernel-level issues, and negotiate massive volume-based discounts with AMD. For them, introducing AMD into their data centers is a strategic necessity to avoid being locked into a single vendor and to drive down costs. They can absorb the software complexity because they have teams of people dedicated to solving it. The second scenario is for a specific type of inference workload. If you have a stable, well-understood model that you've already validated runs well on ROCm, and your primary concern is the cost of deploying that model at scale for inference, then AMD's lower upfront hardware cost can be compelling, but this requires significant upfront testing and validation. The third, and perhaps most compelling, scenario is for the open-source purist and the cost-obsessed researcher. If you are fundamentally opposed to vendor lock-in and believe in the power of open platforms, supporting AMD and ROCm is a principled stand that helps foster competition. And if you are a researcher or a small team with a very tight budget, and you are willing to trade your time and effort for a lower hardware price, then an AMD card can be a way to access incredible compute power for less cash. This is the pro tip that no one talks about: your time has value. You need to honestly assess whether the hours and days you might spend getting an AMD setup to work properly are worth the few hundred or few $1,000s you save on the hardware. Let's talk about the state of the union in 2025. The gap is narrowing, but it's still a chasm. Nvidia is not resting on its laurels. They are accelerating. Their new Blackwell architecture isn't just about more transistors, it's about building dedicated engines for the next generation of AI, like deploying trillion-parameter models. They have a whole stack of software libraries and tools like CUDA, Tensor, and AI Enterprise that AMD simply does not have a direct answer for. The common mistake is to look at a spec sheet comparing an MI350 to an H200 and see similar peak performance numbers and think, aha, AMD is just as good. This ignores the reality of real-world performance, where Nvidia's mature software stack and optimized libraries consistently extract more usable performance out of the hardware. It's the difference between theoretical peak speed and the actual speed you can achieve on a real-world road with traffic and stoplights. For the vast majority of users, from startups and university labs to individual developers and large enterprises, Nvidia remains the default, the safe, and the most productive choice. It's the platform where you can be sure that your focus will remain on building and training your AI models, not on fighting with your tools. So, what's the final verdict? Is Nvidia better than AMD for AI? For now, for most people, in most situations, the answer is an unequivocal yes. Nvidia's lead is not just in hardware, it's in the deeply entrenched, widely adopted, and highly polished software ecosystem that surrounds it. Choosing Nvidia is choosing a well-paved, signposted highway that gets you to your destination quickly and reliably. Choosing AMD is choosing a potentially cheaper, more open road that may be unpaved, filled with potholes, and require you to have a detailed map and a mechanic on standby. Your call to action is this: be honest about your own resources, both in terms of budget and engineering time. If your primary goal is velocity and certainty, your choice is Nvidia. If your primary constraint is absolute hardware cost and you have a high tolerance for technical pain, then, and only then, should you seriously evaluate AMD. The landscape is always changing, and healthy competition is good for everyone, but as we stand today, Nvidia remains the engine of the AI revolution, not because they have the only engine, but because they built the best roads.